Hello there, everyone, and welcome to the UEFI Forum webinar. We'll begin here shortly. Hello and welcome to the UEFI Forum webinar, UEFI Unveiled, Ensuring Transparency in Your Firmware, presented by Insyde. Our presenter today is going to be Tim Lewis, who is the CTO at Insyde Software. Tim, I'll let you take it away here.
Cool. Thank you very much. Welcome to this webinar. I thought I would take this opportunity to go through a topic which is very important to us, whether you're an end user, whether you're a manufacturer, whether you're a software provider, and that is dealing with transparency in the firmware image, and in particular SBOMs. So SBOMs are a device by which you can create a formal machine-readable inventory of software components and dependencies, information about those components and their hierarchical relationships. What's happening is people, as they have heard these news reports about security incidents going on, whether they have been contacted by a security researcher or even a hacker, they realize that they don't always know what is inside their software, and in particular their firmware. Since firmware sits at the heart of the device, it makes them have a sense of unease and anxiety. So one of the things that's happened is over the past several years is that SBOMs, or software bill of materials, have been created, devised, and implemented throughout the firmware industry to give an additional layer of information, and with that information, some sense of security that you know what is running underneath all of your hardware in your machines or in your data center. So when we say that it's a formal machine-readable inventory, that is, it's a list of the software, in much in the same way that a bill of materials for creating hardware, it will give a list of all the software which makes up a particular product. These days, software products consist of multiple pieces, sometimes from multiple different providers. Knowing about where they came from, what they are, is an important part of a sense of security when dealing with your platform and your firmware image. The software components could be anything from source code, they could be data files, and they could be executables. And then the hierarchical relationships: where did the components come from and how are they added to the software? You often have dependencies not only on other executables that are running, but you have dependencies on libraries that get linked in statically or dynamically linked into the product. And this happens with firmware as well. Now, this definition actually came from a document from CISA, which is a government agency, a cybersecurity agency, and from a document called Framing Software Component Transparency, Establishing a Common Software Bill of Materials. And it was just published, created last month. The link that I gave here just went live a few days ago. Now, why do people want to use SBOMs? SBOMs have a lot of information, but one of the reasons that people want to use them is that they want to do license management. SBOMs do contain information, not only what is in your component, but under which license was it distributed. So that means you can get information about how it can be used and who to talk to if you need to do something about it. But license, component identity says, okay, I've got all these different components. What exactly are there? Which components make up the product that I got? Component dependencies, which components are created from other components. Much software today is not a standalone singular blob, which has all of the that you use to run and do the daily activities. Instead, it's made up of pieces that come from multiple suppliers, multiple different components. So understanding what the dependencies are between those is an important part of the SBOM. And then finally, vulnerability management. When you hear these reports on the news about such and such thing having some sort of security vulnerability, one of the questions that immediately arises in my mind is, am I using software that contains that vulnerability, and how would I know? SBOMs are there also to help answer this question. Which components are affected by which vulnerabilities? So why do customers use SBOMs? Well, in firmware in particular, firmware is made up of multiple components created and assembled by many parties, the supply chain, before it reaches the end customer. So starting out its life, a component may start out its life as source code. It then gets compiled. It may get compiled and linked into a particular driver, like a UEFI driver source code. It may get distributed via an IBV, a BIOS or firmware vendor, in their source code, and then it goes out and it's combined with other chipset related or chip related code to make it for a particular platform, and then it may gets moved into being a binary, and then it gets handed off to an ODM or an OEM who takes it to polish it for their platform, get it ready for their particular platform, and it's stuck on a motherboard somewhere. That motherboard then gets shipped to the end customer's IT department, assuming this is a corporate or commercial account, and then that then gets handed to may get handed to an end user if this is a client sort of device, and the end user is the one who actually receives this and receives the final product. So there are many steps in this the process from the source code creator until the end user, many times where software is handed over from one party to the next. And each step in this supply chain is a possible place for vulnerabilities to be found and exploited. So as you can read in the news, they've found many times recently when someone even grabbed a hold of the product when it was in the manufacturer or it was in the warehouse and did something to the product when it was in the warehouse. How to deal with the security, and how does the end user have confidence in what is sitting on their motherboard or what's sitting in their platform? SBOMs give people at each step visibility into the components so that they know that if they are affected by reported vulnerabilities. You will notice that I'm focusing a little bit on vulnerabilities as one of the use cases for SBOMs. It's not the only one, but it's the one that's driving a lot of regulation and development. Because governments are actively creating regulations for OEMs to secure the supply chain using SBOMs. You may have already experienced this where you've tried to working with a particular platform, you're trying to sell a particular platform, and the user of that platform or the buyer has said, can you provide the requirements from this such and such government document and eventually it refers to an SBOM. So what does an SBOM contain? Hey, the SBOM can contain tons of things. There's a lot of room and a lot of variation, but back in the last couple of years, this list of items has become the kind of the de facto list, which people are using. There are lots of other items that can be and are used within the industry, but these are the ones I want to focus on for vulnerability, discussing vulnerabilities. First of all, the supplier name. Who is the one who creates, defines, and identifies the components that went into your product? Then is there a way for the component name? Is there a way to uniquely identify a unit of software from the original supplier? Now, as you know, there's the possibility of name collision is always a problem, but just as a rule of thumb, the advice is, hey, what name was given to it by the original supplier? Use that name if you don't have another specific name. Version. an identifier that's used by the supplier to specify a change in software from a previously identified version. So as it goes forward in time, the version number changes. There are a certain number of canonical version formats and also some other sort of user-defined version numbering systems that can be used. You can have other unique identifiers to identify the components so they can be used up to look up a component in the databases. A dependency is a relationship that characterizes the relationship with an upstream component that includes, like component X is included in software Y. So for example, if your driver links against OpenSSL, you might want the dependency you might want to have there would be the dependency from my driver on OpenSSL. The author of the SBOM data, of course, and the timestamp that shows when the SBOM was created. The last one, the hash of the component, is to, you do usually a SHA-256 hash of the component data that goes into the thing so that you can later on go through and verify the SBOM against the actual deliverable to see if it's still correct. Now, all of these things are listed out in various different US government documents. I've put a link to one of them, the NTIA document, but you can go, even CISA also has another document that specifies this and defines what they are. Now, there are some trade-offs when you're doing SBOMs. That is, you might choose one way of doing SBOMs or another based on different factors. One of those factors is ease of generation. That is, how easy is it to create the final SBOM? Is it how to create it, put it together, assemble it so that it's ready for delivery or ready for usage by the end user or the people who are buying the unit? The size. Obviously, if you're going to be transporting the SBOM over the internet, a certain size is feasible because you have an internet connection. But what happens if you have to put the SBOM physically into the product? That is, does the SBOM have to be delivered with the firmware image, or can it be separate from the firmware image? And how many bytes does it take to store that? Another trade-off is readability. There are different formats for SBOMs. I mentioned a few of them here, but if you're it says in the definition of SBOM that it's formally about machine readability. But to be honest, I want to be able to read an SBOM and just eyeball it to see if it contains the information that I need. So how easy is it to find the relevant information? Updatability. When components are updated, how difficult is it to update the SBOM? That is, when I update the component in a product, for example, I flash the BIOS, flash the firmware image on a platform to the new one, and I want to update the SBOM, how difficult is it to update the SBOM? If the SBOM is stored with the component, okay, that's fine. If it's stored separately from the component, we want to make sure that they're in sync and they don't get out of sync. Or if the SBOM is stored separately, how do you make sure that you update the version of the SBOM that you're storing separately in some repository or in some government database? IP exposure. Are any details of the component IP and design exposed by the product's SBOM? There's some fear that SBOMs contain so much information that they actually tell people how you did your secret sauce for your product. Paperwork. How difficult is it to maintain the SBOM for initial and subsequent versions of the SBOM? One of the things about SBOM is that the SBOMs need to be updated periodically when you update your product. Okay, so if I update it and I have to do this on a continual basis, maybe I do several revisions of my software or my firmware image, or I do it every time that if I find a security vulnerability, I want to issue an update to the component, and I have to make a new version of the SBOM. How difficult is the process for updating that SBOM and then doing the follow-on activities with the final SBOM? Do I have to upload it somewhere? Do I have to give it to someone? Do I have to, and doing this over and over and over again, if we have to do it many times, can be a pain just in and of itself. SBOMs, vulnerability exposure. Could the information in the SBOM be used to attack the product? CISA actually has an FAQ about this one. But the question, there's a worry that, hey, if I say that I have this particular component and I have this particular version of the component, am I making myself more vulnerable to attack by saying to attackers, hey, look at me, I'm painting a big target on my back, come attack my product because I'm using this version. So that's the question. Do SBOMs give that sense of vulnerability? And finally, end user accessibility. At the end of the day, SBOMs are all about moving information about a product and it's what makes it up from the people who made the product or made the different pieces down to the end user. So the question is because the end users many times, especially in the client space, the end users are the ones who are actually responsible for updating their platform, updating the firmware to remove a security issue. And if they don't know about it, then the security issue never gets updated. So end user accessibility. Can the end user find whether the product's components possibly contain a vulnerability? So those are some of the trade-offs, and I'm going to mention some of those again as I go through this next section, which talks about a few of the options within UEFI about how SBOMs are stored in the platform. Now, these different vendors use different methods among these, and there are many more possible ones or variations, but I would just want to go through, highlight a few of them. First one is where the SBOMs are stored in each module. That is, when the module is compiled, a certain amount of space is left within the executable. For example, in UEFI, within the FFS or the firmware file system, PECOF section, there may be a space to put the SBOM information inside each one of the executables. For other regions in the firmware, you have to find some other way to put the other information about other regions in the firmware. For example, if you have an FSP or an option ROM, somehow how are you going to get the SBOMs for those? Or are they going to contain their own SBOMs, or do you need to create one for them? They are obviously not executables in the same way that the executables for EFI are, but you still may need to refer to them. The advantages of this particular method is, hey, the SBOMs are self-contained. They're built into each of the executable images. It's so that if you update that executable, you're automatically updating the SBOM. Which is quite convenient. You don't have to worry about maintaining something outside of the executable. When you create the executable, you also create the SBOM. Another option that I've seen used within the industry is that SBOMs are stored in each region. For example, the hash and the version number are stored per firmware volume or per region within. So that is, each region has its executables, and then it also has another data file or data piece, which is the SBOM. So for example, in the case of UEFI, where you might have 2 or 3 or 5 firmware volumes, each firmware volume might contain an additional file whose contents are the SBOM information for each of the executables within that region. So this is similar to the previous one in the sense that you have you do it at build time, you do it at the same time, and it also has the same issue that you have to figure out how to do the SBOMs for other regions within the flash device, such as the FSP or the option ROMs. But in this case, when you do an update, you're not doing an update by single file. You do an update to the SBOM with the entire firmware volume. This is used in case where vendors like to they might want to update a firmware volume as a whole independently, but they don't update individual components by themselves. So you put the SBOM information in the same firmware volume where the executable is located. Another option is that where the SBOMs are stored separately entirely, there's another flash region that just contains SBOM information. Now, I'm going to point something else that I haven't mentioned so far. I'm using the word co-SWID in these diagrams a lot. SWID is a very common SBOM format, and it's normally using ASCII text. But there's a binary encoding of SWID called co-SWID, and it's very useful when you're embedding a SWID into a firmware image. it's a byte encoded version of SWID. It is the same level of functionality as SWID, but it's much smaller because it uses byte encoding for all the different fields. So you'll see that in my pictures, just I'd used it for convenience. But in this case, this particular one, the SWID SBOM is stored separately from the firmware volumes and separately from anything else. And it's so that means that you need to when you update you either a component or a firmware volume or a binary, you need to update this binary, the SWID binary image as well. Now, it is the entire product's SBOM in one place. It's all together, so you're not looking around searching executables and firmware volumes and for SBOM information. All the SBOM information for a given product, a given firmware image is right there in a single place. And following on from that, you could take an option which seems to be very popular these days, that you're not going to deliver the SBOM, whether it's in CoSWID format or it's converted from CoSWID to SPDX or Cyclone DX or SWID text format. Is stored outside of the binary. That is, when you deliver the binary for the image for the platform, you also have a separate file, which is the SBOM, and that SBOM is treated separately. So it's stored outside. It's distributed, and I'm not going to talk about exactly how you would do that, but the advantages are you can do it. Smaller means that it doesn't affect the size of your firmware image. If you're worried about the size of your firmware image, then you're storing it separately. It's on another device entirely, and it's separately distributable. That means that someone can take this and use it to verify the contents of a particular flash device just by you have a separate file. You could theoretically run a tool which compares the contents that is in the SBOM with the contents that are in the flash device. And since it's maintained separately, you don't have to worry about someone tampering with it in the flash device at the same time when they're hacking your system. You've got it locked away. What are some use cases? Well, the use cases that are most common, first of all, you want to verify the SBOM. Compare the SBOM contents versus the firmware image actual contents and report modules that don't have any entry. So you want to make sure that the hashes match, and you also want to see if there's any modules that showed up in the flash image that don't show up in your SBOM, which means someone managed to insert a whole new component. You want to be able to export your SBOM. That is, you want to export your SBOM in a variety of formats. What we're finding is that each company, each software package that people are using for security response has a preferred format for their SBOMs, and being able to export them in that format or convert them to that format is important. You may want to list the licenses. You want to list the licenses for all the different firmware modules. You may want to do security checks. You want to check a SBOM against a vulnerability, a VEX or vulnerability record to see if that vulnerability affects the components which are in the SBOM. And then you might want to use this for external viewing. That is, this SBOM may need to be handed off to someone else because they want the information. They, as a user of the device, may want to know about the SBOMs. There's lots of open source tools. I do recommend USWID, which is a tool by Richard Hughes. There's the GitHub for it. Makes it very easy to create firmware SBOMs, and it's designed to help insert those SBOMs into an executable, but also it's just really good at creating CoSWID SBOMs. It's very, very useful. This is a tool from Insyde. It can be one of many tools. But what it does is it goes through a firmware image and it compares what's in the SBOM versus what's actually in the module and sees if they match, and if they don't match. In this case, you can see that it says there are some missing modules. That is, that the module is not found inside the executable, but was in the executable but not found in the SBOM. So again, it's just a way of visually verifying that the SBOM is correct compared to the actual firmware image. So this doesn't solve all the images. There are still a lot of things that need to be done in the industry to make this work, especially within firmware. CVE matching is a tricky thing for firmware because most firmware today is built off of software packages that are basically SDKs, such as EDK2, which means there's heavy customization of the source and the libraries, which that means that the same component may share the same exact name and the same exact version number, but they're actually been modified. They're different when they come to their binary version because they use a library or they have source code modifications. So that means that it's hard to do a match, CVE matching, using just the name and the version number that is in the SBOM. So the industry needs to figure out how to handle this for SDK sort of solutions like EDK2, and a lot of the firmware vendors who are members of UEFI have to deal with the same thing. How to meaningfully track security issues back to the binaries, from the binaries to the source. Another remaining issue is how much dependency information should be included in the SBOM. Are we talking about this is especially true of libraries, because libraries lose some of their identity when they get statically linked into drivers. Should all library dependencies be included, or some? Should we do one layer deep of library dependencies, or all of them? For example, OpenSSL is a good example. It's a single library that's used in EDK2. It's very common, but it also includes dependencies on 4 other open source projects. So should I list all those open source projects or not? So some people have taken one side of this and said, I'm not going to list any. Some people have said, I want to list everything. Some people have tried something in between. So that's an issue that's still ongoing in the industry. Partial updates. In cases where it's possible to update just part of the firmware, maybe a single firmware volume or a single region or even a single component, how to handle SBOM updates, especially when the SBOMs for the region or the component are stored separately from the component itself in the flash. How do you handle that update? You have to make sure that they stay in sync. That is, when you update the flash for a particular driver that may be in one part of the flash device, how do you make sure that the SBOM also gets updated at the same time? What happens if the flashing process gets interrupted partway through? So some storage solutions are chosen to split out those SBOMs, which means separate updates are possible. You also have things updating like FSP, updating PSP, which need to be dealt with for this kind of thing. Which leads us to their call to action. First of all, I can't stress this enough. And if you haven't already been asked to do it, you're going to be asked to do it soon. Make sure you can produce and verify a complete SBOM for 100% of your firmware's code in SWID, SPDX, or Cyclone DX format. You know, even if it's not a perfect SBOM and doesn't necessarily contain all the things that you think are relevant, at least having something which is 100% complete for your firmware's code, make sure you can do it. Because if you're not asked to do it today, you will be asked to do it tomorrow. The second thing to do is, hey, UEFI has an SBOM subteam, and that subteam is actively working on some of these questions, a lot of these call to action questions, trying to standardize how to do this, trying to give best practices to the industry about how to do it for UEFI firmware. And so if you're interested, they talk about all this stuff all the time. You can join, listen in, and it will help you to get a better grasp on what the whole SBOM thing is and some of the detailed aspects of it. Hey, having get that, we get to the questions.
All right there. Our first question here for you, Tim, is does an SBOM require a source code disclosure?
No, an SBOM can be done purely on the binary aspect of the product. So it can be done. In fact, we have some products that have already shipped. We Insyde have already shipped some products, and we're being asked to generate SBOMs on the binary images that were shipped on platforms that were shipped, 2, 4, 8 years ago. So
Alrighty, our next question here says, many firmware code base are now in open source Git database, similar to Slim Boot Loader. How do we ensure such a critical boot firmware is not tampered with by malicious developers?
Well, the idea is that the SBOMs in particular are from the perspective of the end user. So the end user is going to want to look at the SBOM, be able to get a trusted SBOM. The SBOM should be able to be delivered by, in this case, you're talking about open source, the Git repository. They should be publishing open source, some method, usually a hash or something to show what the image is that they produce. You have to make sure that then you have to match that hash against what is actually generated by you when you build the product, or when you're looking at your product. Does it match the hash? So that hash is very important. Many firmware code bases, they have they can be tampered with like anyone else can. So you have to go back and make sure, are you getting genuinely good code in the first place?
All right.
Maybe I didn't understand the full context of that question, but are you talking about the source code, or if it's talking about the source code of the binary that's generated from that source code? But anyway.
Our next question here, does a list of the software components I include expose my intellectual property?
Well, since the software components that are listed in an SBOM is usually just the name of the component, unless your name of your component contains your intellectual property, then not really. Yes, it might say that you have used a certain library, or you might have used something like that. No, in general, it shouldn't be. In fact, in the CISA FAQ about SBOMs, it specifically says, "Hey, it's not a big worry item."
Our next question here says, is there already a reference implementation of SBOM in EDK2?
I don't believe so yet. I know that they're working on it, but I don't know that it's been implemented as at this point. There was a branch that was checked in. There was a branch that was checked in, that had a one particular implementation, but I don't know that that's been standardized as a reference implementation.
All right, our next question here. How can the customer view the SBOM information of their product?
It's a good question. So right now, there's since SBOMs are stored in so many different formats, you have to talk to the individual vendor. Where did you get your product from? And they would have some information about how to get the SBOM for that product. Some vendors like to verify that you are their customer before they give out the SBOM information, and other people, like some Insyde customers, have it built right into their firmware. So you really need to talk to your vendor.
All right, Tim, our next question here says, given the CISA security concern about SBOM data aiding attackers, since SBOM should be considered sensitive information, they should have necessary security controls. It looks like you are proposing to store the SBOM in the system where it can be found by attackers. In some security models, the host OS is often considered compromised. Isn't that like providing all the details about building security systems on the door of the bank so the bank robbers know all the vulnerabilities and strengths? Do you think we should have provisions for encrypting these SBOMs so that they are only usable by trusted partners that have the right to know about the SBOM?
Sure, it's an interesting point. I think that one of the things this may be true for commercial customers, but you have to consider there are two types of customers. Who is the one who can do remediation for an issue if they detect that something has been compromised? For a commercial customer or a data center, the end customer for the product really is the data center owner, right? So they need, of course, they need to have that information. But in many cases, the person who can make the decision to remediate a security vulnerability is an end user, like my grandmother. So if my grandmother, if my grandmother finds out there's a security vulnerability and it affects her laptop, am I going to want to have to go through the SBOM? Am I going to have to worry about decrypting the SBOM for my grandma so she can know whether she's affected by the vulnerability? So it's a difference between, I would say, commercial and consumer users. For commercial users, sure. But for consumer users, I think they need to have the power in their own hands to understand the SBOM.
All right, our next question here. Do you think OEMs will have to release SBOM with the firmware update together in the future?
Absolutely. I think that the question is where you have to release it to. I think that is the big question. I know that there's some regulations now that are requiring U.S. government people selling to the U.S. government to have to disclose the SBOM to the U.S. government. But are you going to have to put it out there publicly? And if you're putting out there public, where does it have to go out publicly? Does it have to be at the same place that people get their firmware image from? That you're going to download. You download your new BIOS image and you get the new SBOM at the same time. I don't, how that's going to work out. It's still in process, and I think people need to pay attention to watch what the new regulations are going to be, because it's certainly for businesses. It's putting requirements on businesses about having to disclose SBOMs when they release the firmware images.
All right, I think we have time for one more question here.
Mm-hmm.
Next question says, does an SBOM increase my exposure to license violations?
Well, it's no more than, not in particular. I think that for one thing, most firmware, especially UEFI firmware, is based on BSD licensed code in general. Even for GPL code, it doesn't necessarily give firm indication that you're using a particular GPL licensed item. And if you did, you can. It's not in the CISO FAQ for this. It doesn't seem to be a big, a serious issue. So I don't think that, unless you're planning to go and deliberately publish a bunch of GPL code and not give the license, not give the code that you did per the GPL, I think you're okay.
All righty. I want to thank everyone for joining us today for the UEFI Forum webinar. If you have more questions following today's webinar, we do have a live interactive Microsoft Teams Q&A for the opportunity to chat directly with Tim here. So we have this information listed on the screen. We will also be putting it in the announcement message. Here are the references for today's talk. And thank you again for attending today's webinar.